Hello, Math 109 college algebra students. Looking at section 1.4 today, which is getting into imaginary, also known as complex numbers. To do this properly, I probably need to give imaginary or complex numbers, put them in the context of all the number systems. And I think your homework asks questions about this too. So I like to do this kind of as a story. All right. A long, long time ago, there was a man, a long time ago, and he had a goat. And he called that goat, And then he got himself another goat, and he called, since the first goat was called, then he had to call that new goat, And then, I'm telling you, this was a really long time ago. And then he got like 50 goats, and he got so tired of grunting that he came up with a brilliant idea. And it was going to be certain sounds and symbols that would represent certain quantities. So he now, instead of grunting so much, he would say, "You are goat number one. Number one. And you are goat number two, and you are goat number three, and on and on and on." And that set of numbers is called the counting numbers. Counting numbers. Also known as the natural numbers. So 1, 2, 3, 4, 5, all those, all the way up to whatever, are called the counting or natural numbers. All right, then something bad happened. All of his goats got sick and died, and he had to come up with a very sad number called what? 0. He had none, no goats. So you add 0 to the mix, and you still got 1, 2, 3, and on. But once you add 0 to the mix, that's called the whole numbers. So the whole numbers, all right, the whole numbers include the counting numbers, but they add an extra number to it called 0. All right. Then he got on his luck again. He got some more goats. All right. But this man became greedy and arrogant. And he had, I think he had maybe 20 goats. And his friend had 50 goats. But he thought, I've got the fastest goat in the ancient Near East. I'm going to get me some more goats by betting everything I've got and more on my fast goat. So he told his friend, I'll bet all my goats to all your goats. So basically he's betting more than he's got. He's betting 50, but he's only got 20. I'll bet all my goats against all your goats that my goat is faster than any goat you got. And of course, you know what happened. He lost. And so he had to come up with another new set of numbers to represent negative stuff. And so you have the negative numbers like -3, -2, -1. But it also includes the numbers that we've already talked about: 0, 1, 2, 3. So with the negative numbers, right, he had to actually get some goats before he could have 0 goats. So those are called once we add the negative numbers to the mix, those are called integers. The integers include the whole numbers and the counting numbers, but they include negative numbers in the mix. All right. Then one day, but his friend was nice, and he let him keep one of his goats. And so he kept that goat, and he got another goat somewhere, and they multiplied. He had some more goats again. And so one day he got tired of eating just all the nuts and the berries, and he was too tired to go out and try to hunt a deer or something. So he said, I'm going to have me a goat pizza. So he made himself a goat pizza for him and his family. And he cut that pizza up into different sections. And he said, that's a new kind of quantity. I'm giving you not a whole pizza. I'm giving you a part of a pizza. So he realized there's actually values between these values, right? There's a value between 0 and 1. And so when you introduce those values, some of those values, that is, it's called the rational numbers. The rational numbers is any number that can be written as a fraction. Fractions. Okay, that would include like 1/2, -7/5. It would include also decimals that end, like 3.76, because 0.76 can be written as a fraction. It's 76 over 100. All right, or decimals that repeat, like 0.3 repeating. A decimal that falls into a repeating pattern can be written as a fraction as well. 0.3 repeating is 1/3. It also includes the whole numbers that came before it, because if you have a whole number like 2, you can just always put it over 1 and it becomes a fraction. So anything that can be written as a fraction fits into the category of the rational number. So it includes all the numbers that came before it. But it also includes the numbers between the numbers, or at least some of them. All right. Then something very strange happened one day. One of his goats got struck by lightning. Boom, exploded goat. And there was little goat pieces all over his property. And he walked outside and he found a piece of goat and he said, I wonder how much of a goat that is. And he couldn't figure it out. He couldn't grasp it in his mind. And so that's when we introduced something called the irrational numbers. Irrational. The irrational numbers. These are numbers that can't be written as a fraction. All right, so, and actually the irrational numbers far, far outnumber all of these other categories put together. All these rational numbers and such. The irrational numbers, the numbers that are between these numbers that can't be written as a fraction, there are vastly more frequent, they occur more frequently than the rationals do. The reason these are called rationals is because any number that's a fraction can fit in our minds. Our minds can grasp it, can comprehend it. Like you can imagine, an eighth of a pizza, or even, a 100th of a pizza. You can grasp what that is. But an irrational number is called irrational because it can't fit in our minds. Our minds cannot fully grasp them. They will never do it, and because they can't. They won't fit into our conception of reality at all. Some of the kind of classic irrational numbers, you know one that's really famous, right? Pi, which is like 3.14159, and it goes on. This is the ratio of the circumference of a circle to its diameter. We will never know what that number really is. I think we know thousands and thousands of digits by now, but we will never know it. Not truly. Not its true, exact, real value. All right. This another number like that is E. We'll learn a whole lot more about E much later in this quarter. E is 2.718, and on and on and on. It's called the natural number because it occurs so many places in nature. And there are an infinite number of these irrational numbers. These are just a couple of famous ones. So anytime you have a decimal that never ends and never falls into a repeating pattern, that is an irrational number. It is a completely separate group than the others. It does not contain the others. It is a separate category. All right, I'd love to tell you more about this. I really would. Like, there's a lot that if we were in class together, I would take some time to explain some things to you, because this is mind-blowing. All right, I'll just maybe tell you a couple things. All right, your height is an irrational number. Okay, if you measure your height, and let's say you think it's maybe close to 5 to 6 feet. All right, so here's 6 feet, and you came right there. You're close. But if you zoom in on it, right? Zoom in on that, and actually, here's your height, and here's 6 feet. And so this is like 6.000317015 inches. And so, but then you get that and you measure your height again, and it comes pretty close. But if you zoom in on that, it turns out that here is your height, and here's that 6.00, what did I say? 317.075. But you're actually 6.00317.07130056513 inches. But then you measure that again and you zoom in even farther. You get my point? It's going to continue on forever. Your height, you actually don't know it. You can't know it. You don't know your height. You don't really know your weight. You don't know your age. All these things are irrational numbers that we actually don't. You can't know it. Not really. Now, what you can know is that it is closer to 6 feet than it is to 6'1". So you are not, telling a lie when you say, when somebody asks you your height, and you say you're 6 feet. What you're doing is you're estimating it in an educated way, because you're closer to 6 feet than you are to 6'1". So what this does, I'm going to get a little philosophical. It kind of destroys the modernist notion that man's reason can accomplish anything, and no, it can't. There are things that we can't do. We can't know. We'll never know. No matter how hard you try, forever, you still won't know it. It also destroys the postmodern notion that just because we can't know something, can't know everything, doesn't mean we can't know something. Just because we can't know something fully, that means we can't know something useful about it. See, we'll never know pi, right? But we can know that it is that 3.14159 is a really good estimate of it. In fact, we can use that to do a lot of good. It reminds me of a verse in Deuteronomy 29:29. It says, "The secret things belong to the Lord, but the things that are revealed belong to us and to our children, so that we may do all the words of this law." In other words, you will never know pi. That is a secret that is not revealed to you. It's not for you to know it, but you can know a lot about it. You can know a whole lot about it, and you can know enough about it to do a lot of good with it. So we can't know everything, but we can know a lot. And the things that we do know, the reason we know them is so that we can do good with them. So anyway, that's a good thought for me when I think of irrational numbers and how ubiquitous they are and powerful, and how they show up all over the place. It's just kind of some divine humor there, I think. All right, let me continue on with these number categories. All right. The next set of numbers that we need to talk about are the real numbers. Real numbers, see, since the irrational numbers and the rational numbers, the one thing that they have in common is that they are grouped in the real numbers. Okay. So that means if you look at this number line, and here's 0, and here's, 100, and here's negative 100. But it continues on past 100 and past negative 100 as far as you can imagine. And every number that can be represented on that number line is included in the real numbers. But that means that there's something that isn't included in those real numbers. So let me get back to the goat guy. The guy who had his goats. All right, one day he thought about that lightning striking that goat and how powerful that was, and he thought, it'd be cool if I could do something to harness that energy of that lightning, make it work for me. And so he started delving into electricity and getting into some alternating current and direct current and all that kind of stuff, and impedance and resistance and ohms and all this kind of stuff, and electrical engineering applications. And he actually found that there were some times where he wanted to solve this kind of equation, x squared equals -4, and he thought to himself, if I want to solve that equation and I take the square root of both sides, what can multiply with itself to get -4? 2 times 2 is positive 4. -2 times -2 is also positive 4. What in the world am I going to do to find the square root of -4? And so he came up with something I'm going to teach you about today called the imaginary numbers. The imaginary numbers. And the imaginary numbers are stuff like this, and they actually have some uses, not only in electrical engineering, but in some other ways that I won't get into too much today. But he defined something. He said, I'm going to let I be defined as the square root of -1, or we maybe better said, I is that which, when it is squared, it equals -1. So you can define it either one of these ways, kind of. I mean, this is really the most precise mathematical definition, but I don't know why my computer makes those things do that. But this is also a good definition to think of sometimes. That's helpful. So anything that has an I in it, or the square root of a negative, is classified as an imaginary number. It's kind of unfortunate that it's called the imaginary numbers, because they're not really imaginary. They're just in a different plane. They're on a different line, a different number line. They used to think that negative numbers weren't real, that those were nonsense, but they have a use, and so we don't think of them as not real or absurd anymore. Imaginary numbers, maybe they should be called lateral numbers. I think somebody proposed that they should be called lateral numbers. I think that would be a better choice, because students, when they hear imaginary numbers, they think, what in the heck do I want to learn about something imaginary for? But they have uses. All right. So now we have a greater number system, a number category. We call them the complex. Oh no! Why do you do that? Complex numbers. The complex numbers include all the imaginary numbers and all the real numbers. So every number falls into the category of a complex number. What about just the number 3? See, a complex number has a real part and an imaginary part, like a plus bi. What about just the number 3? It's just a real number, isn't it? Well, it doesn't have an imaginary part, but it does. It's just that its imaginary part is 0. So you could write 3 plus 0i, that's the same thing as 3. Well, what about the number, -2i? It's just imaginary. It doesn't have a real part. Well, you could say it actually does. Its real part is 0, so 0 minus 2i. But anything that has a real part and an imaginary part is called a complex number. So every one of these numbers that we've talked about before fit into the category of the complex numbers. Complex numbers are the grandest set of numbers that we have currently conceptualized in math. All right, those are all the categories of numbers. All right, I think I'm going to stop the video here and make a part 2. So I'll call this part 1, and I'll see you again in part 2.